Command start. 2, 1.
New Shepard blasted off from Blue Origin's test range in West Texas at 11:36 a.m. EDT, 1536 GMT, kicking off today's uncrewed test. About 45 seconds into flight, at an altitude of 16,000 feet, 5,000 meters, the capsule fired its onboard escape motor for 2 seconds, blasting itself hundreds of feet clear of the booster. Today's flight was the toughest trial yet, because it forced the capsule to traverse twice through transonic velocities, the most difficult control region, during the acceleration burn and subsequent deceleration. The new Shepard capsule landed softly under parachutes in the Texas desert as planned, raising a huge plume of dust as it hit the ground. And then, about 3 minutes later, the booster came in for its own touchdown, landing vertically on the launch pad. The rocket's landing was something of a surprise. Bezos predicted a fiery death for the rocket in his blog post last month, writing that the thrust from the escape motor would likely knock the booster off kilter, causing it to crash and die in a massive fireball. Today's test marked the 5th and final flight for this particular new Shepard rocket. In November 2015, the booster became the first ever to land after a space mission, and it has now repeated the feat 4 more times.
We're waiting here for the mains to come out. Again, the purpose of this test is to make sure that that crew capsule escapes, and it looks like things are going well for right now.
Booster is 85,000 feet and climbing.
But Phil, there goes your beautiful booster up towards space. It looks like it also clean firing of our BE-3 engine. 110,000 pounds of thrust.
Right, we should note 110,000 pounds of thrust off the pad, but actually we have to throttle down shortly after our plane's escape, simply because while we lost the aerodynamic benefit of the crew capsule,
and there go the mains.
Okay, so those 3 mains are reefed right now to keep them small. The reefing will remove shortly to fully expand, as you can see. All 3 mains.
There you go, full inflation. Phil, as a reminder, we also have that retro thrust system on the bottom of the crew capsule to make sure that the touchdown is even smoother for our astronauts.
That's right.
Just as a reminder, that's also going to kick up quite a bit of dust out here in Texas. Yeah. We've heard it looks, again, looks a bit sporty, but really it's full.
It continues its ascent to space. Like I was mentioning earlier, we actually have to throttle down the engine as soon as the escape happens, because what happens is, while you lost the aerodynamic benefit of the capsule, you also lost 8,000 pounds. And so if we kept going with our full propellant load at full thrust, we'd actually overboost and go even deeper into space. But let's focus back on the crew capsule.
That's right. You see the hills of West Texas in your screen. A nice smooth 15 miles an hour or so on that crew capsule. If you're an astronaut in there, it'd be a nice smooth ride. It would have been exciting, certainly, but most importantly, you'd be safe, right?
You'd be finally catching your breath and watching those mountains come up around you.
Phil?
Absolutely. All right, so the booster has just passed apogee and it's beginning its re-entry. So you can see the speed is picking up quickly. We've got about a minute until we hit our re-entry. Apogee, of course, is the maximum altitude of the rocket. So its vertical velocity went to 0 and now it's re-entering the atmosphere.
So Phil, we've got a couple of subsystems up there in that ring fin. We've got the drag brakes that are gonna come out at about 20,000 feet. They're gonna cut the speed in half. We also have the wedge fins that come out of the ring fin. That's to help with stability, in addition to the ring fin itself, which helps centralize the pressure. It keeps the rocket upright as it's coming into land.
Correct. The ring fin shifts the center of pressure backwards, and we're about 12 seconds out from those wedge fins deploying. And that also creates additional stability, passive stability for the booster during reentry. And there they go.
Again, I want to thank our viewers for joining us for this live test of our new Shepard rocket. So far, it's been a successful test of the in-flight escape system, and we're just waiting for our booster to come down for, fingers crossed, what we hope to be the 5th landing of this exact same booster.
So we're at 120,000 feet and falling. 100,000 feet. Now the sequence will be really quick here. The drag brakes will deploy, and shortly after that the BE-3 will restart. And we'll wait for that smooth, gentle descent onto the pad.
And again, it's the ability of that BE-3 engine to thrust down all the way to 20,000 feet to give it the precise, soft landing.
All right, so drag brakes are fully deployed. Let's wait for that BE-3 engine to fire.
And watch that speed falling pretty dramatically.
There she goes. Look at that.